Hello and welcome to problem number 2 on the conditional probability test. What's the probability of being in a sport? See, the thing you have to think about with each of these questions is it a question about anybody in the whole group, or are we looking out of a conditional probability where it's only a subgroup, it's only a certain number of people? Is it given something so we're only looking out of a smaller group, or is it just out of anybody in the whole school or anybody in the whole population? So in this first one, it's saying, what's the probability of being in a sport? That's asking, out of the whole school, what's the probability that somebody's in a sport? The first thing I did is I totaled these up. So there's 31 people in the school. And this is just asking probability of being in a sport. If you just asked anybody at random, what's the probability they would say, oh yeah, I'm in a sport? Well, there'd be 818 people that would raise their hand out of the whole school, out of everybody that you survey. So it's this. Okay? This one is saying, though, what's the probability of being in a sport and being in the band? So now they would only raise their hand. We're still asking everybody, but they would only raise their hand if they're both in a sport and in the band. How many of those people would say, yes, I'm in a sport and in a band? Just these 14, right? These people are both. So the probability of both of these happening is just 14 out of 2131. Now the next one says, what's the probability of being in a sport or in the band? We're still asking everyone, so it's still out of 2131. But remember with or, we got to think, okay, how many people would raise their hand and say, yeah, I'm in one of those things? Well, these 818 people would. They're all in a sport. They would say yes, right? Plus, these 222 people would all say, yeah, I'm in one of those things. But we double counted these 14. We counted them here and we counted them here. So remember, you need to subtract that overlap so we don't double count them. Can I get somebody just to add these and then subtract to get a total? 1026 out of 2131. Which tells me a little bit about half the people are in at least one of the other activities. But we don't want to double count the people that are in both. I'm going to subtract, or I'm going to erase this just so we don't make it confusing later. Okay? Next question says, what's the conditional probability of being in the marching band given, this is a really important word, you know the student plays a sport. So we're asking about the probability if they're in a band, but we're not asking the whole school. We're asking the people that we know play a sport. So it's not out of 2131 anymore. It's just out of the people that are in a sport, out of these people. We know that they play a sport, so we're just going to ask those people. And what's the probability that one of those guys is in the band? 14 out of 818. Not out of everybody, just out of that smaller group. That's conditional probability. You know something about it first. What's the probability of anyone being in the band? Okay, well, is this out of a smaller group or asking the whole school? When it says anyone being in the band, we don't know anything about them. There's nothing else special. So my denominator should be the whole school. The whole school. Good job. 2131. And how many people are in the band? How many people would say, yeah, I'm in the band? Well, that's all of these people, 222. Both those that are in a sport and not in a sport, 222 people would say, yes, that's me. Okay? And then the last question is really an important one. It's saying, are they associated? To know if they're associated, we have to prove if they're independent or not. And the proof for independence is always this formula. Does the conditional probability equal the regular probability? So in this case, we can say, all right, well, we're looking at band and sports, right? So does the probability of being in a band, given that you're in a sport, is that any different from just being in the band? Right? If those are equal, then they're independent, and I guess being in a sport doesn't affect being in the band at all. Right? So let's look at our numbers. We already calculated it. We already found probability of being in the band given sport was this. 14 out of 818. Does that equal the probability of just being in the band? That was this. And you see I'm looking for, oops, 21, 31. I'm looking for what formula are you using? What are we trying to see? Don't just throw down numbers and expect me to figure out what your numbers are. Is this true? So can I get some calculator friends to punch this up as a decimal? Yes, what's the first one? Speak up. 0.01. Okay, let's call that, right? Does that equal? Okay, does 1% equal 10%? No. So apparently only 1% of the people that are in a sport are in band, but 10% of the overall people are in band. So I guess you're less likely to be in band if you play a sport. So we would answer, these are not independent, which means they are associated. One affects the other.